Oh yeah, I forgot.
All right, here we go. Today we're going to start, instead of our solve it, we're going to start with the launch activity that allows you to collaborate, but instead of looking out of the book, we're going to kind of do it like whole group, and then in small groups, and then in whole groups, small groups. Today I have called it contemplate, then calculate. Contemplate, then calculate. Everybody say contemplate.
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 Eyes up here.
Wait, I'm feeling the same yet.
Okay. Alright. For the time being, I want you at a level 0 because I'm going to explain some very specific instructions about this contemplate, then calculate. If you need help before we get started with the group work, we're going to do raised hands. Once you're in group work, what do you think you can do for help?
Before me.
Yeah, a pair or 3 before me, okay? The activity is going to be what I call C2C, contemplate, then calculate. And there shouldn't be any moving around. You have pen to paper in your journal or on the whiteboard in front of you, okay? So everybody say it again. Contemplate.
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 Then calculate.
Then calculate.
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 Contemplate, silent hand, means what? What does it mean to contemplate something? Adrian.
To think about something.
To think about.
Oh.
We can keep going.
So kind of,
Yes, ma'am.
to talk something, talk it out.
To talk it out.
Analyze.
To analyze.
Concentrate.
Ladies. I need everybody to 0. Because we've never done this before. You won't know what's expected of you. Anaya, contemplate.
Is to concentrate?
Concentrate. So we've got concentrate, analyze, think about, talk about. We've got contemplating and then calculating. What is calculating? Raising your hand silently. Deza. What? To work it out. What else? Calculate.
Oh,
Yes, ma'am.
calculate.
To solve. To answer. Okay, let's talk about this. Raise your hand. The difference between contemplating and calculating. The difference between the two. If I want to contemplate something versus calculate something. What's the difference here? Talana?
To contemplate means to think clearly of what something's asking. To calculate means to do operations.
Okay, so we're thinking and then doing. Anybody else can summarize? Yes, ma'am. Do all of the normal journal updates that you would do and then pay attention to this. You won't need your journal for this part of the activity. Yeah.
It's like planning. The contemplate is like planning and then contemplate how to do it.
Excellent. So the contemplating would be like the planning process, and then the calculate would be like actually constructing your argument or building or solving or the doing. Okay? Here's what's going to happen. I have a question that I'm going to flash on the board for you that has to deal with what we learned about last class. Can anybody give me a raised hand for what we learned about last class? Tiana?
We learned about exponential functions.
Exponential functions. And we compared them
With linear functions.
with linear functions. So we talked about exponential versus linear. We talked about identifying them based on their equations, their tables, their graphs, okay? What I'm going to do is I'm going to flash a problem that's about last topic on the board. Listen, we've never done this before. Give me eyes so I know that you're paying attention. I have B's eyes. I have Hannah's eyes. We've never done this before. Thanks, Tay. Listen. We are going to look at this for 6 seconds. I will count. Literally, you only have 6, okay? That's not me exaggerating. You have 6 seconds to look at what's on the board. And guess what? It's contemplating, so you're not allowed to put pen to paper. There is no calculating in the first 6 seconds. Don't need your journal. Writing utensils will be down. You are not talking. You are looking, and you are contemplating, okay? All of the things we said go into contemplating. Thinking about, looking at, okay? Analyzing. So you're pure contemplation for the first 6 seconds, and then I will give you instructions about how we are going to calculate or solve the problem. Why do you think it's appropriate for us to spend time breaking down or contemplating a problem before we take the EOC in 3 months, 4 months? Yeah.
So you can think about what the problem is actually.
Yes, to break down the problem, to think about what exactly it's asking you to do. So this habit that we're going to be starting today is about contemplating problems before we go in and attacking them, okay? So I'm going to flash this off the board, 6 seconds. After 6 seconds, I'm going to clear the screen so you can't see anything. And here's what I want you to be looking for. I'm going to write down all of our observations right here. I'm going to write down all of our observations. No observation is too big or too small. I don't want you to solve the problem. That is the calculating part. For contemplating, I just want you looking at and analyzing the problem. So for example, I'll flash it up. You have 6 seconds to look at it. I bring it back down, and I say, what did you notice? I want to see every hand in the air with something to contribute to our discussion, okay? Something. It can be a minor detail, something really, really small. It could be a really big, monumental detail. It doesn't matter, okay? Contemplate, then calculate. No observation is too big. No observation is too small. You will contribute to our discussion in the calculation part, assuming that you contribute to the list of observations we're going to make. Okay? So conversation level is 0. There shouldn't be any help for this part because you literally have 6 seconds to make some kind of observation. The activity is contemplating. No moving around the room. Participation is not pen to paper. B, will you change that for me? What does participation look like for this 6 seconds? Because it's not pen to paper. Tyler.
Looking at the board.
Looking at the board, tracking the board, okay? We are not putting pen to paper for this portion. We are contemplating. And as soon as B takes her seat, we will have 6 seconds. And I'm going to flash it up, and I'm going to bring it back down, okay? No oohs, ahs, like that. No fidgeting, okay? We need silence and concentration. Ready? In 3, 2, 1, 0. All right, 6 seconds. That was really, really quick.
Oh my gosh, why'd you do that?
Really quick. All right, so what I want, level 0, because we're not collaborating. Where's my pen, my purple pen? Thank you. All right. No observation too big or too small. You had 6 seconds with it on the board. I want every hand in the air for some kind of observation, okay? Yes, ma'am.
I noticed, can we talk about that?
Yeah.
I noticed that it was multiplied by 4.
All right, so there was some kind of operation. The operation was multiplication. And we're thinking one of the factors was 4. We'll put by 4 maybe, okay? Talana?
The X is going up
X was going up by 1. So the X row was going up by 1. So the change in X was 1, 1, 1. The loopy-loops were 1. Taylor? All right, so we had question marks, right? Question marks, and we think what we were supposed to do with the question marks was fill in. Okay, so we think we're going to fill these in.
This one, the 1 is X.
The person is Y.
So the Y was going up by 4, and we think the operation was multiplication? Okay. Anaya?
The last number was bigger than all the other numbers.
All right, so the last number, does anybody remember specifically what the last number was?
130.
All right, last number was the biggest, according to Anaya. Does everybody agree that it was the biggest number we saw? Anaya, was the last number that you saw with the Y's or the X's, inputs or outputs?
X's.
It was the X's?
Wasn't that bottom of the Y?
Right, so let's get an agreement here. Was it the X's or the Y's?
The Y.
The Y's, but it was the biggest number for the Y's, okay? And it was what?
128.
The last number was the biggest Y, and it was 128. Okay, good, Anaya. Any others? Yeah.
Can we talk about the question?
Yeah, you can talk about the
The
question.
question was linear versus exponential.
Linear versus exponential. So if we really wanted to answer the question, we need to use this math vocabulary. What does linear mean?
That'll make the good wrong
It has
with
no
nothing.
change.
So this would be a straight line on a graph
A rate of change that is constant.
or a constant rate of change. Okay, and exponential, we just learned about it, that's new.
Not a straight line.
Not a straight line.
And change the rate of change.
Yep, not straight line or changing, not constant rate of change. Y'all can see all this? I'm trying to do it big so that we can all use it later. Okay? Anybody else? Taylor?
You can find a rule.
Okay, so we've been looking for a rule. What's another word for a rule? A function. What would be another?
Equation.
So maybe an equation. What do we tell younger students to look for when they see tables? Yes, ma'am.
To see if it has a rate of change.
A rate of change or a, what y'all say? Pattern. So we're going to be looking for, I'm going to do the eyes. Looking for patterns. Right? What other observations did y'all have when you saw this? I didn't want you to solve anything. What else did we see on this problem?
It was a table.
It was a table. And it had how many rows in it? Did y'all notice?
4.
4 rows?
No, 2 rows.
2
and
rows.
4 columns.
4 columns. And going back to what Taylor said about the question marks and the filling them in, how many things were missing from the table? 2 things were missing from the table, right? So do y'all remember what it was that was missing? Do you remember where in the table they happened to be?
I know. I know.
So somewhere in so there were 2 question marks?
Yep.
Okay. And we were thinking they were in like the 3rd row or
For X, it was the last one, and for Y, it was the 3rd one.
okay. So the 4th or the final value of X and the 3rd or like a middle value for Y. What else did we notice? We're going to need these observations. We need as much here as we can to help us do the calculating part. So help us make the most use of the contemplation that we can. What'd you say? Yeah, like more about what you happened to notice when you looked for 6 seconds. What drew your eye? Okay. So we got it was white. What was the writing?
It was black.
Black ink. What color was the table?
It was purple and gray.
And you know why I picked purple, AJ? Why? Why did I pick purple? And I'm writing in purple. Why do you think I picked purple?
Favorite color?
It's not my favorite.
But orange.
I think it's appropriate for my Algebra 1 class is all. A lot of us like to write in purple. Alright, Brianna? Alright, so the 128, which we already talked about being the biggest number, it created a gap. What do you mean by gap, Brianna? Okay, so there was like an 8,
8, 7, then it was
and then a blank, and then 128.
Yes.
Okay. So it's like an outlier in our data. Good. Anything else that we want to address before we go into calculate mode?
No.
We got nothing? Okay, so listen very carefully to the champs and the expectations for the calculate. You successfully contemplated and observed. Now we're going to move into calculate. Okay? In front of you is a whiteboard that can serve as like your scratch paper if you don't want to write in your journal today. Wait until I finish instructions. At a level 1 to 2, with the people in your immediate surroundings, just press the middle button. That's fine. All right, at a level 1 to 2, the help that you're going to get is no longer coming from a raised hand like me or Miss A. Where's the help going to come from?
My peers.
Your peers, or where else? Where else can you look in this
The
room?
book. Or your notes. The walls. Or the observation board.
Or the observations that we just made, okay?
The walls.
I'll give you like 2 seconds, okay? So yes, you can use the observations that we made or your peer to solve this problem. The activity is going to be the calculating part. There's going to be no moving around, and this time participation is not only tracking the board, but you can be doing pen to paper or pen to whiteboard. And you will be discussing and asking your neighbors questions while you fill in the blanks. Remember, the question says not fill in the blanks. What did the question ask?
Which one was it?
Is it linear or exponential? So not only do you have to fill in the blanks, you have to use what you came up with in the blanks to answer the question, okay? There's any way to handle this. I heard Kira say graphing. There's any sorts of ways you can solve this. So here's your challenge. Once you think that you and your group have the answer to the problem, it's going to be your job to come up potentially with a second way to solve the problem, because not everybody thinks like you. And the goal is after 5 or 6 minutes, You notice I went from 6 seconds to 6 minutes, okay? After 5 or 6 minutes, hopefully, we will all have the right answer and we will have come about it 2 or 3 different ways, okay? All right, so I'm going to put the problem back on the board and let's see what y'all can come up with. 5 to 6 minutes. Huh? Yeah, it's a review from last class.
It was on 7.
You don't have to write it in your journal, you can just use the whiteboard. I see some people's strategy is to start by writing the problem. Some people are making note of the observations.
It is? Yeah. So is it not exponential? Yeah. Because it's rate of change then. Right. Exponential is changing. It's like 2 times 8, 2 times 4 is 8, 8 times 5, 30 times 6.
Okay, what makes you say that right away? You've already got an answer. What makes you say that?
It's constant. I just know it's 4. I know it's 32. I know what you got.
Okay, do you know what that number is?
Yeah.
Okay, isn't it already on the board for you? And it's here, right, in the observations. They said it was 8 blank 428. Yep. So you can use what?
It is exponential.
Right?
You know, it's never mind.
So I see something.
It's linear. Oh, I know why it's linear. Because look, I'm trying to show you.
No, explain to me further.
Because
Yep.
2 times 8. No, 2 times 4 equals 8. 8 times 4 equals 32. 32 times 4 equals 128. Not competition. I know that from 128. I mean 2048 again. Oh my goodness! I had got to 512.
That's not the answer to the question. That's filling in the table. Is it the answer to the question? What's the question now?
I got to 512. And then I got 512. Then I got 1,000.
So here's my question. Do you look at it and decide that it's
So
going
if
to
I
be
get
exponential
double
before or after you
24, and then I get 2048.
Alright, so before you were already assuming it's going to be exponential. How are you going to use the table to prove that point? Whether it's right or wrong, you have to use the table to prove your point, right? So even if it's right and you're right, you're jumping the gun on exponential.
That's how you win the game, I guess.
How does filling in the table help prove your point? Like why did you need the table to determine that? Okay, so if you were to plot it, it would look a certain kind of way. You can prove that.
That's how I like all the.
Look here.
No, I don't. What are you talking about?
Straight line versus not a straight line on a graph. What if you chose not to graph? You could look at what?
Yeah, and I was saying, oh,
The rates of change.
Then I
Right?
had almost
And how do you do rates of change?
I had almost. No, they're recording.
So check your loopy-loops and see, do you have a constant rate of change? Pattern, what do you have? Okay, good. Yeah, I have a question. I'm coming, 1 second, I have a question. Okay, so.
You know the password?
Why is it multiplied by 4? Or is one happening every time?
You go on my phone, you let me get it right for it. I won't be stupid on it.
Okay, so the x to y like ratio, you did your division is like 4. Like it's 4 is happening every time. So why is it linear? That's the word I want to hear. It's not the difference because 2 to 8.
That's just the cover, but the book is
8 to 32 is a difference of like 20.
No, that's the
Use that
That
vocabulary.
book is really good too. No, that's just the freaking name. Oh my god. Yeah, he do. He do say that, but he do say that. But
So you're saying x is 1 up by 1 every time, and the y is being multiplied by 4 every time. So if the same thing's happening every time, a lot of people assume linear. But Talana just told me we were looking for something called a common difference, so that the spaces between each x value should be the same every time. So Deza has taken it to her chance to go ahead and plot.
So this will have right.
See if the space between your y's will create a straight line.
She was a babysitter. And then they get
Is it gonna be a straight line?
Thing.
No.
And then like
Is it gonna go straight up? Is it gonna get big really fast? Is it gonna go smaller really fast?
they get together.
What's the rate of the change?
What?
So what happens if you made this 5? What would go here? A really big number or a number that's the same distance away as 32? It is going to curve eventually because it's getting bigger really, really fast. Every time you multiply by 4, your quadruple curves. So if you did that,
Oh, it's not. It's not.
it wouldn't be, even though there's a function and a rule that's happening every time and you've got that consistency.
So what? That's 4. 4. I'm talking about this is 4. That is
The answer is 4.
show you.
No, you already did that.
I'm going to show you my.
Exactly. So the rate of change is constant or changing? Fair.
We already got it.
All right, ladies, you've got about
This is 4.
1 minute.
This is 32.
You know that. We already said that. You erased the whole board.
1 minute.
Actually,
You erased it.
this is 32 and this is 4. Oh, over that, like 2 seconds.
All right, let's bring it back down at 5. Almost done with this part of our day. 4. I need all senses. 3. Eyes, ears, mouth closed. 2. 1. 0. I need 1 spokesperson from each group to be prepared to contribute something to our calculate portion. If somebody in a group before you speaks out or shares out something that you want to piggyback off of, please do, but you are not allowed to sit in silence, okay? So between the 1, 2, 3, 4, 5 working groups, we should be able to come up with like a 5-sentence summary conclusion about our answer to this problem. All right, let's start my back left table and we'll kind of snake around the room. Back left, I need 1 spokesperson to contribute something to our calculate.
Starting
The function is exponential. So the answer to the question is exponential. Let's take a show of hands before we move on. How many working groups agree with exponential? 1 working, 2, 3.
Oh. Wait,
So we've got 3 other groups besides the original. What's this one mean?
Is that a negative?
What's this one mean?
What?
Are we in agreement that it's exponential or not?
No.
No. Okay. So we're not. We've got 1 working group who wants to contribute something different to the discussion. All right. I need everybody tracking the board. Cornelia, put it away. All right. So, back group has contributed with exponential. Next group has contributed with what? Linear. Okay, so we've automatically got 2 opposing views.
Yeah, I thought we did.
Ladies, not done yet. Middle group, how would you like to contribute to our calculation part?
That no, that is going, like they said, going up by 4 times 8 times 4 is 132.
Okay, so you're going to tell me that 32 goes here based on a pattern of multiplying by 4. Okay, and Brianna? Alright, Brianna said exponential. Piggyback off of what they said. Either fill in my table for me or tell me why. Alright, so we're talking about even though there's a pattern, there's gaps or spaces. Okay. Brianna has piggybacked off exponential, but has said because of gaps. And then the last group?
What would I say exponential? But can I say something? Like
Yeah.
I said it was linear because because you said linear was a constant rate of change. It's still going times 4 times 4, not changing.
Ladies,
No.
everybody needs to be tracking the board.
No.
Cornelia,
Linear.
tracking the board.
It's like a multiple, like.
So are we in disagreement at this table?
Yep.
Alright, so we've got a linear and
When
exponential.
it's linear, and it's not linear, because it's not multiples of 4. It's
Yes, ma'am.
lining up time.
Alright, bring it down. Bring it back. I understand. I'm glad that we care. Let's bring it back because I have a solution for how we're going to handle it. Yes, ma'am.
So we chose
Exponential.
because of the it goes by multiply by 4 each time, but if you do like individual, it's not a constant because it's jumping numbers.
So I see jumping and like gaps here, piggybacking off Brianna. What is the word, Talana, that you use that might make a common difference? Everybody remembers the word common difference from your notes?
Yeah.
Right? So common difference was if you looked at the x's, the rule was +1, right? Yep. The difference between 2 and 8 is how much?
6.
4 if you were multiplying, but the common difference, 2 to 8 is 6, right? What's 8 to 32? 6?
24.
Yeah.
Bigger than 6, right? And 32 to 128, is it 6?
1.
No, okay. So here's what I want you to do. If you were working in a group that thought it was exponential, please find the group that thought it was linear and explain to them your thinking. And if you were linear, please find a group that was exponential and share with them your thinking. And let's see if we can collaborate to come up with one group answer. So within your group where there was a disagreement, come up with a mutual decision. Over here where there was kind of like some what do we do? Come up with a mutual decision.
Look what she's doing.
Okay? I'll give you like 2 minutes. 2 minutes to see if you can change somebody's mind.
I was about to write you a nice one. I was about to write you a nice one. Look what she did.
Hey, you guys, come on.
I just about to write you a nice
2 minutes to change somebody's mind.
Even though
It's not me doing this.
Wait, that's exponential.
Either Adrian needs to change your mind or you need to change Adrian's.
Exponential.
why?
Because the rate of change is the same.
You said they go by 4 each time.
No, when the rate of change is the same, it's adding by 4, multiples of 4, and it's not multiples, it's times by 4.
Okay, I don't get it.
It's multiplying by 4, not multiples of 4.
Right here.
That's why it's not rate of change.
It says that it's still going by the same thing
And
each
it's not
time.
a constant.
Not like going
Yeah.
4 and then 5 and then 6 and then 3.
Okay, it is, but they not
Like,
like,
even though it's multiplying by 4.
it's not adding by 4. See, I'm gonna show you. Let me show you. I gotta show you. Let me show you.
This is the real class of Jackson.
You understand what she was saying? What would be your argument
Okay,
factor?
first of all,
why
the
it
reason
should
why
be
it's
linear?
linear, one, is because it's
There we go, right there, that's me.
So you saw this times 4 happening over and over again. This later says 7 4.
I'm
So
gonna
it's
show you.
saying over and over again. It's your constant.
Okay, show me.
Now remember last
If it was
week,
linear, this would be,
you can find the
it's
difference
adding
between all
by
these numbers
4.
that is the same.
That's like the
What
multiples
operation?
of 4.
I know the person that was coloring it.
But I still knew the answer.
Subtraction.
But
I don't know
why
if
can't
So
you
it's
follow
subtraction.
that?
The difference between
Because
all
the
your outputs.
exponential is jumping. Okay.
But
You see
no,
how-
wait,
you can't
is it
find
over
a
straight
common
line?
exponential.
Is it over straight line though? Is it over straight line?
And another
No,
way to
it
put that would
curves.
be the graphic, right?
And it says that we have a common
Difference
difference.
between and then all of a sudden you're plotting 128. That's not linear.
Oh, wait, hold on.
Difference means what operation?
Division.
Subtraction, right? So common difference is either adding or subtracting, right?
See, you don't know how to back us up on this.
I don't know if
I'm gonna draw the graph, and if it's a straight line, then it's linear.
She said when it's exponential, it's curved. I took it.
No, but if she said if it's a common difference.
All right, let's bring it
I
up.
wasn't here last week, and I know.
And 4.
Wait.
All eyes 3,
I'm
Two.
still going with exponential. I don't care.
1, 0. Has anybody learned something new before we close out that they would like to contribute? They've changed their minds. They have an explanation. Brianna? Ladies, I can't hear her. She's right here. Yeah. So common difference, we would be looking for subtraction across our y's. And even though there's a common pattern or a common multiple, common products, common factors of 4, it is not a common difference of 4. If you graphed it, would it curve or be a straight line?
Straight line. Curve. I did straight line.
It will curve. It will be getting very tall, very fast, okay? If you need to take the time to graph it to prove a point, please do.
Okay.
Because I think that will help you see it. It'll help you visualize it.
Yeah.
Hang tight.
On the graph, it's going to fall.
Hang.
It's going to be there.
Yeah. Alright, so here's what's going to happen. We'll come back and we'll do more contemplates than calculates with EOC style questions. This was just meant to review for you. I think it would have been too easy if we had seen a graph. So you kind of had to build a table for this part. Any questions?
Yes.
Tayana needs a question.
Yes. I have a question.
Yes, ma'am.
So if it's multiplying, it can't be linear.
No, it can't be if the difference between here and here, here and here, here and here is the same.
So if it was multiplying by 2, it would be linear.
So like if 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 is 6, then you have 2, 4, 6.
Oh, that's how you're doing it?
I
Obviously,
did
why?
So if you were going x to y, x to y, x to y, it's different than going y to y to
She
y.
did not say
I
that.
did say that.
Everybody following? Alright, so Talana had asked us to do one that was linear to prove a point so we can see the difference. And we'll do that, okay? So let's go ahead and move into
Ask us, is it linear or exponential?
Is it linear or exponential? Ask you that? Is it linear or exponential? Oh, when I put the new one up there? Okay. Alright. Let's close out this contemplate and calculate. Thanks for participating, guys.
I didn't know how you were doing it. I thought you were doing like 2 times